let's move to our fourth module. So the fourth module is on failure. So any equipment or system has finite life of working even though it is designed and manufactured with a lot of precautions and care. For example, consider the case of a pen. If the pen is designed and manufactured to write up to 1 kilometer, and if it's not written up to 1 kilometer, then it's a failure. Likewise, if a tire is manufactured to run for 25,000 kilometers, and if it's only lasts for 20,000 kilometers, so there is a loss of 5,000 kilometers, then it's a failure. So failures are bound to occur after some period of time, which makes the equipment completely inoperable. The term failure refers to malfunctioning, stoppage, crash, damage, or deteriorating of any equipment or system. It is also defined as the inability of a machine or equipment to perform the intended or specific job under specified conditions. For example, our normal ballpoint pens are manufactured for writing in normal ambient conditions. At the same time, if the pen is not working at a high altitude places like the Mount Everest, then it's not a failure because it's not made for that condition. Okay, so let's move to the failure rate. So failure rate is defined as the frequency of failure of an equipment or a system. So the machines are normally expected to have one of the three types of behaviors with reference to the failure that occur. So the three types are: first one is rate of failure is decreasing. That means the total failure rate is decreasing. That is the condition of improvement. Next one is the rate of failure is constant. That means throughout the process or throughout the working of a machine, the rate of failure is very low. Rate of failure is, remains constant. That means the condition is consistent. Next, the rate of failure is increasing. That means the condition is deteriorating. So let's see the graph. So here you can see that the first case is the rate of failure is decreasing. Here the graph is plotted between the failure rate and the time. So here you can see that the failure rate is decreasing. It's the first case. Second case is the failure rate is remains constant, and the third case is failure rate remains increasing. Here you can see three graphs for the failure rate increasing. Here there are two geometrical profiles, and here is a linear profile. Okay, so next the definitions of failure, simple definitions for failure. First one is the inability to perform intended function, like if a pen is not working. So next one is any damage that disturbs the continuity of production, which means if the tool of the cutting tool of a drill is not is damaged, which disturbs the total continuity of the production. That's a loss of. Next one is the loss of asset availability. If the drill bit is not available, that means the loss of asset availability. Next one is the deviation from existing state. If the tool post is slightly bended, that's an example. Next one is not meeting the target expectation. If the lathe is working for about 100 pieces per hour, and if it's meet up only about 90 pieces, then there is a loss of 10 pieces. Okay,